So today I'll be talking about dynaTrace Ajax edition. Just some words on myself. I'm part of the dynaTrace Labs team around Ajax edition. So we're building Ajax edition, and our major work that we're doing is developing performance management tools, best practices, not just for the web part, but also for Java and .NET. But today we'll focus on the Ajax edition. So we're really glad to be over here and give you some insights on dynaTrace Ajax edition. So when I was first exchanging emails with Luke on what we are going to talk about, I told him, let's focus on the JavaScript analysis and a bit of the rendering analysis. That's where dynaTrace is really strong at. But then when I was working on the slides, I realized that the product somehow evolved from where it started some time ago. And today there are actually a couple of use cases that you can use it for. And what I decided to do today is to walk you through those different use cases what you can use the product for, because it's more than just a JavaScript profiler. It's more than just giving you hints where to improve it. So I put in the 4 major use cases around the whole topic of web performance optimization, where dynaTrace fits in and where dynaTrace can provide value. So that's what I'll be talking about today, and I'll give you some outlook on the future, where we're heading. So let's talk a bit how it all began. So what was the motivation for actually building Ajax edition? First of all, we looked at all tooling out there for browser diagnosis, for browser profiling, given the background we had in server-side tooling, and realized that there were a couple of things that we did not like from profiling approaches. So first of all, we don't like averages. So we want a real number of real method execution. We don't want to have a start profiling, end profiling, average across all that was in there, and then figure out how long this method was for the specific user click. So we thought this simply didn't work out quite well. Second point we didn't like was aggregation. So just putting everything together, 200 user clicks, different JavaScript execution, putting it into one big call tree, and having all that aggregated data in there. This is pretty great if you really have a CPU-intensive part or want to just find out some performance-relevant parts. You might find out that method XYZ is the method that's actually responsible for causing most of your CPU load in the browser or taking most of the time. But when it then comes to analysis, you have to figure out of all of those aggregated metrics, what did they really call, which parameters did they pass in, like CSS selectors that you passed in, things like that. And in an aggregated view, this is simply very hard to figure out what was really responsible for this. The third part was asynchronous calls, specifically XHR calls. So what we wanted to see is, if I send an XHR request, I also want to see the whole trace when it comes back. So I want to have this asynchronous call seen it in one single trace. So how long does it take me from the user clicking on a button, the XHR request being sent, response being received, and finally the user interface being updated. So I want to see this in one single trace instead of having to browse through some profiling data that I have there. Next point is the level of details. So we wanted to have more details. We wanted to have in there rendering information, parameters of method invocation. So all those details that I wanted to simply help me to identify the root cause and really optimize my code at the end. And finally, we wanted something for IE, because there was nothing there for IE, or there were profiling tools by Microsoft, but it was not what we thought a really serious web developer will require to use in his everyday life. So what did we do? We implemented JavaScript tracing. So the big difference is here that we really trace each and every single invocation of the JavaScript engine and create a separate call trace for all those invocations instead of putting it all together in averages. So you now can distinguish each and every single call, and you have support for XHR and async calls. So you can really see one single trace in your within your application and following that single trace without having to work with all those average values in there and some figuring out of some aggregated profiling tree what it really looks like. So if you have a certain button click, you can follow it on its way to the server and then back to the client. Next part is rendering support. So one of the major things for us was to really have rendering support in there. So we wanted to show people how their coding affects the rendering behavior of the browser. So rendering was one of the major things that we wanted to put in there. Parameter capturing, also capturing all parameters, so you see what were the parameters functions were actually called with. And for sure, support for Internet Explorer. So we decided to build a tool initially for Internet Explorer 6, 7, and 8 at that time. So this was somehow where we were last November when we launched Ajax Edition the first time. So it's not even a year ago. And thanks to a lot of people like Steve Saunders, who has promoted it, John Resick from jQuery, and a lot of other people have promoted it. A lot of people have been downloading it, have been started working with it, and also have started to give us feedback what they use the tool for, what they would require from the tool to provide from a functionality perspective. And we simply took that input and worked on the Ajax edition, released one version after the other. At Velocity, we announced the 2.1 beta version, added functionality over and over, and at some point, people told us, you know, your tool is getting more and more complex. There's more and more in there. It's really great to have this JavaScript tracing, but you're building this around that and that around that. And now there's more and more in there. And actually, for this talk, I really sat back when I wanted to work on, okay, how to present the JavaScript tracing functionality in there, and said, wait. It's actually really true. Today, we're really supporting a lot more than we initially wanted to do by just doing the JavaScript tracing part in there. So we have reached a point today where we would say we are doing more than just JavaScript diagnostics, which we still believe is a big deal in itself because it's simply helping you to make your code faster. And we came up with 4 different use cases that we see today supported in Ajax Edition, or what you can use it for, which also affects, as we've seen, different target audiences to who you present this information to. And I'd now like to go through those use cases and at the end then demo how to use it in those different use cases. And I hope it makes also the tool look easier, to understand the process we have in mind behind using dynaTrace. So let's start with the first use case, benchmarking. That's a use case that just came recently into the product, but we see a lot of uptake now in the whole industry. Benchmarking your site against other sites. How good are you performing compared to your competition? There's also a lot of businesses now just emerging that benchmark one site against the other, so you can go to different websites like Web Page Test or other commercial vendors. You type in different URLs, your own ones, the ones of your competitors. You benchmark the loading time against each other, just that you have some feeling, how's my site doing against what my competition is doing. And what I've done here is I prepared a simple sample of benchmarking. So how to talk to your management that you should do something about improving the performance of your website. You could talk a lot about that you would need to invest in infrastructure to make static content delivery faster. You need better network infrastructure. You, at the end, should get rid of those 300 marketing plugins that you have on your website that are simply slowing down the download and first impression times. And talk to them in these very technical terms, and they simply might not get the point. Or you do what I did yesterday. So I just moved to California, so I have no car. And I simply wanted to find out what is the fastest car rental site when I look at them. So what I did, I simply opened up my browser, typed in the ones that I knew, which are Avis, Hertz, Enterprise, and Budget. Not making any advertisements. There are others out there as well. And what I was just interested in, how are those different sites behaving against major characteristics that are important regarding end-user experience. So first of all, we ranked all those pages with a ranking algorithm that's in some ways similar to what you have available in PageSpeed or what you have available in Wieslow, and cut the 3 most important metrics that we see tell you about how end users feel about your page, where we have first impression time, so the first rendering after the page download has started, the onload time, so triggering off the onload event, and the fully loaded time, so the time when all the content is actually loaded. So this also includes content that you load within your own load event handlers. So especially if you work with deferred loading or async loading, we also see, okay, what kind of loading did you trigger later on, and how long does it take until all of this content is loaded. This metric is actually quite interesting because we saw for a lot of pages that they're loading more and more at the end, thinking, yes, great first impression time. But for some of them, we saw that it takes quite a long time until the page gets fully loaded or not. Whether it's important or not to your page still depends on you. And we have two additional metrics here, a server time metric and a client-side metric. So we also tell you how much time you spend on the server. This is actually all the time from sending a request to getting back the first byte of the response. There is some network in that, but that's the closest you can come to that. So how much time you overall spend on your server, and how much do you spend on the client executing in JavaScript. So I think if you have to deal with performance for Avis, you could take this to your boss and maybe get some resources looking into this a bit closer. So this is the first use case that we see today on how to use this. And I just recently showed this to our internal marketing guys, and they asked me, so could I do the same for our own company website? Could I just type in those metrics and just use it for that? I said, yes, just type them in. Just open a browser, type in the websites you want to have a look at, and you get some benchmarking on how you compare to others. So we have really built this small snippet that really makes it easy for you to compare against different sites here. So when you then have found out that you want to optimize your web, that you have some problems in your website, or that you want to make it even faster, is when you come to the second use case that we see, which is optimization. Optimization is always up to you whether you can make certain optimizations or you cannot make certain optimizations. But like other tools, like PageSpeed is doing, like Wiselow is doing, we try to give you some hints on where to optimize. It's not a lot of difference in here what we do compared to what other tools are doing. We're just providing you the same functionality for Internet Explorer. The part that we're simply adding that we explicitly take JavaScript executions as well as server-side execution times into the game here as well. So we tried to somehow reduce this to the max, not showing you 200 rules or whatever. What you could do, we tried to sum it up to the 4 most important parts that we see where people normally can optimize. The first one is the caching behavior of your browser. So although there has been information out there for a long time how to optimize browser caching, it's still what we see in our engagements. One of the major problems that people don't get caching right, and suddenly you tell them how to do caching right, the site speeds up. Second part is how do you utilize the network. So how many requests do you make? How big those requests are? Could you save on certain requests? The server-side performance, which we decided not to leave aside, because we've simply seen that especially e-commerce side take quite some time on the server as well. So if you submit a search to a travel agency and you're the responsible part for the backend systems, you also want to know how long does it take the backend systems to really get you back the search results. So you can have the fastest front-end user interface. If your backend systems are slow, you still would have to optimize on that side as well. And finally, JavaScript and Ajax performance. So we also took into account JavaScript and Ajax calls. So specifically, we take at JavaScript blocks, interactive blocks that take over a certain time and immediately show you those blocks, as well as XHR requests. The best practices behind those 4 areas are similar to what Wiselow and PageSpeed are offering. We just try to condense them a bit further down. So either you go where the best practices, or alternatively, you use what we call a KPI-driven analysis. So what we have built is a KPI page that some of the web performance analysts view on the web page. It's a pure number-oriented view of those metrics that we've actually been tracking ourselves as well, or when being on consultancy engagements. So what we basically see here on the top part is the major metrics that we normally want to look at, which is first request time, first impression time, on load time. The metrics we discussed before, how much time we spend on the network, what was the overall size of that page, how many requests was the overall page, how many XHR, Ajax calls were in there. So we try to sum up all this information on one single page, which should give you some indicator on what the health of your actual page is about without looking into all the optimization hints. This information can, for example, also be used to trace the performance over time. So is it getting better? Is it getting worse? Did you really come down on the number of requests compared to your last release? It's a very in-depth look, just looking at key performance indicators of your page and then deciding where to tweak those performance indicators. Below we have, we're showing you a list of the different types of content that you're downloading, giving you an indicator of the total size, how many could be cached, what's the size of the cached ones, what's short cached content, so that's content that can be cached for up to 48 hours, as well as the not cached content and not cached sizes for the different MIME types that you have on your website. So you see, how is it with HTML, how is it with Flash content on my page, how do you do with images, CSS files, and all those different content types, so that you immediately see, okay, obviously we're only caching 20% of our CSS. This is really what we want to do. And finally, information on domains. The domain information shows you how many requests you make to certain domains, what the size of those requests is, what you have in DNS time, wait time, connect time, server transfer times, as well as a rough estimate as download speed from a specific domain while we were recording that metric. It's still an estimate, but it still helps you to understand which domains are fast and are slow. This is especially important if you're downloading a lot of third-party content that's served by third-party providers like ad providers, some marketing tooling that you're using, whatever. So you want an ad provider actually to bring additional value to your website and not necessarily slowing it down because it has a bad connect time. Actually, by that way, we discovered a problem with our own CDN provider, who obviously had a problem in their DNS, with their DNS server, which simply take an awfully long time to do the DNS resolution of the CDN, which is not what you want your CDN provider to do. So this is really the high-level view, figure only, to figure out how the website is structured, how you can analyze it, and giving some hints, okay, where you could optimize. I'm skipping the demo now to the end because for the people on the phone. The third part is diagnosis. So when we found a problem, we actually want to diagnose it, right? When it comes to diagnosis, I think that's been the strengths of the product from the very beginning, and we have a twofold way on how to diagnose your applications. So what we found more and more people using is a visual way to look at how your application is behaving. I'm sure everybody is familiar with waterfall charts for network downloads. So what we simply did is we added rendering and JavaScript to this chart. And you can also visualize events like mouse clicks, mouse moves, keyboard enters, and have a visual look on how your web page is behaving. So you would see, okay, if I'm executing this JavaScript up there, which might be on the top of my page, you will see the network downloads waiting for that time during the download. So it gives you a more complete picture of your website than simply showing you the network traffic. It adds, as I said, rendering and JavaScript in there. And as we will see later, you can immediately drill down from here to the respective JavaScript code, network code, and the like. For us, this has somehow become a kind of a starting point for the analysis to understand how that website is behaving, how those different browser components like the JavaScript engine, excuse me, the DOM, and the networking layer are interacting with each other. Especially when you then have to tell people how to do optimization, so how the way they have implemented their web application is affecting their performance. It's often easier to show it to them in a visual way than to do it using call traces and plain numbers. What you could do additional here is we support custom events. So you can imagine if you run a test that has 10 different test steps, this chart might get rather big, you know. first I'm typing something, then I'm searching something, selecting a search result, then a pop-up opens, then I type something in the pop-up and close it, and then I should find all this information in the timeline. So this might get a bit tricky and a bit difficult. So what you could do is either, while you're using dynaTrace or using the browser interactively, just add what we call a marker. So you just add a custom event that says, okay, here I start typing into the search field. Now I'm done with this action and starting this action, doing this. And you can do the same also from within, for example, a Selenium test. You simply trigger a JavaScript, a simple JavaScript method to add a marker to your recordings in here. And you get this really visual impression where we normally start to work from. So if you see excessive rendering here, because normally if there's excessive rendering there, the JavaScript block right in front of it was someone responsible for it, so then I'll go down into this JavaScript block there. What we also started to do is to pre-analyze this whole lot of JavaScript that's going on in your application. So especially from non-expert users, we have heard it's really great information that you're showing there, but there are so many JavaScript executions. What should I actually have to look at? Where should I start? What's the critical parts in there? And we also realized whenever we are doing analysis, we are always doing quite the same thing, actually. We are looking for JavaScript blocks in critical areas of the page interaction, looking how long it takes to execute them, and then we analyze those blocks. We simply thought, okay, why aren't we simply automating this task? So what we do is we look for all JavaScript blocks on the page execution that take longer than 20 milliseconds for execution. We have taken this 20 milliseconds because that's what we've learned so far is the threshold when you experience something still as being responsive in an interactive way. But we're open to discussions on changing the threshold. So far it's 20 milliseconds. And we list all JavaScript blocks that are JavaScript functions that take longer than this time. And we also automatically list CSS selectors of frameworks, selector queries of frameworks like jQuery or Prototype, because that's where we have seen a lot of performance problem. People just type in those complex queries, get back the results, and at the end, they're taking awfully long. As you see in this sample, we have this method here that's called 8 times this getElementByClassName. What we can do then on the right-hand side, we can drill up where was this method call, what did it call itself, or jump directly to the JavaScript call, to the JavaScript implementation of this specific method, where you here see on one of the sites before how they've implemented that.
So in the JavaScript display that you have there, it's very nicely indented and syntax highlighted. Does the product actually take minified code?
Yeah, so we automatically reformat the minified code. Okay. The question was that the JavaScript here is nice color-coded and indented, whether it also works with minified code. The answer is yes, it will reformat the code. You can switch to the original file, so you actually have the possibility to switch to the minified file as well, which you normally don't want to do, but you can. However, if you have the minified file and have the obfuscated variable names and everything in there, you would see that those instead of the ones that you wouldn't actually want it to see. The point is that currently, I think only Closure supports kind of deminification. That's something that we wanted to actually put at some point in the product, that you say, okay, you run this against the production website, you get real production results, but when you then have to diagnose it, I want to somehow match up the JavaScript that I got with the initial JavaScript, resolve it, and then being able to debug it from what I have with the minified code. But the recommendation so far is simply switch for those kind of testing to the real JavaScript files that you're using. And finally, there's the deep dive. So this is what I say the heart of dynaTrace. So that's the purest way of looking at the data that we're collecting, which is our pure path view. So what you see here is every single JavaScript execution, every network request, every rendering activity, everything ordered in a chronological order. And you get, as you see here, the exact call trace of each specific JavaScript execution, getting you actually all details that you normally need to do to really investigate performance problem, find out how code is working as well. Like on the lower pane in the contributors view, you see those methods in the call stack below the current method and how much they contribute to the overall execution time of this specific method. So if you just go to the top, look at the contributors, you will immediately see which methods took most of the time, have been executed most often, like DOM manipulations or whatever. When you click on them, as you will see later, you will directly jump to the position in the call stack where this method was then actually called. The stack element is also very nice. You know, when you have JavaScript that uses a couple of frameworks, you might have very, very deep call stacks, and you might find this one rendering call. At the end, you wonder, okay, who triggered this rendering down there? Then you simply use the call stack, which simply shows you the call stack up to the top level, that you get an understanding where this was actually called. This is specifically important. Think you're using a framework, and your framework somehow triggers some rendering within or does some extensive DOM manipulation. You want to find out which framework method did I call that at the end resulted in this non-performant behavior. And here you simply go up the call stack, pick the method that you actually called, and then see the impact of your custom code when it interacts with the framework code. And finally, you also have the JavaScript view in there as well, so you can also have a look at the JavaScript. That's what I would call the expert view within dynaTrace. So you can decide how deep you want to go or who wants to use it from this very high-level recommendation-driven approach down to really deep dive code level. This is what I would call the engineering view, what engineers normally want to have a look at. And now let's come to the fourth use case that we see, which is continuous testing. There were a lot of requests that asked us, how can I automate performance testing with dynaTrace? We have our tests that we run regularly, and we want to get regular test results and want to automate this testing. So I want to have every day in the morning, I want to have a comparison from code base yesterday to code base today. Can I do that, and how can I do that? The first answer is yes, you can do that, and I'll also present the second answer, how you can really automate performance testing with dynaTrace. Actually, there is exactly the setup that we're discussing right now is in production at dynaTrace. So dynaTrace is automatically uploading results for all URLs that the public show slow instance is monitoring. On a daily basis, we upload those URLs and deliver those metrics to show slow. So here's what it's actually doing. It's just requesting URLs. And then there's a test runner, which is implemented in Java using Selenium, driving Selenium RC, which then drives the browser. Ajax Edition is connected to that browser, collects all those metrics while the test case is running. And as soon as the test case finished, meaning the browser closes, it then automatically uploads all the collected performance information to show slow. So what it's actually doing is sending a JSON beacon to an HTTP endpoint. That's what it's doing. This is now running at dynaTrace in production for over 1 month. And it's doing pretty fine, and it's pretty easy. So you just take your current test cases, and you can automate them and then collect the performance information. What you have to do is actually quite easy. You just have to set 2 environment variables when you launch a browser. So you can do this in Selenium RC. You can do it in Water. If you're using WebDriver, you just have to pass it to WebDriver, which simply says activate the dynaTrace agent. So the dynaTrace agent is implemented as a plugin for IE, and it listens for that environment variable. If it is set to true, the agent will get activated automatically. You can pass a session name that you can later on use to identify that code. That's all you have to add to your Selenium tests. And just for reference for later on, here are a couple of parameters that you have to set within dynaTrace in the ini files that will allow you to define the upload endpoint, a portal URL, so you can directly jump from dynaTrace to whatever performance portal you're using, which is then opened up automatically, as well as specify that the upload should happen automatically. So by default, it's not uploading your results automatically, because by default, it would upload to the public show slow URL, and you might not want to be your performance test results being visible publicly. So the last part of the presentation, before we come to the demo, is giving you a bit of an outlook about the future. So where are we heading to? As you've seen, there's been quite some change for us from being a pure diagnostics tool to those 4 use cases that we have right now, whereas definitely the automation use case is what I would say the one that's most getting more and more important now, that most people are interested in. I'll give you also some other directions that we're moving to. First of all, we are planning to release version 2.0, so to have the GA of 2.0 around the 1st anniversary of Ajax edition. So it's not even a year old, the product yet, which will mean in November, mid of November, we will release version 2.0. The big points in there will be like the whole benchmarking part that's already in there. The automatic uploading will get a bit more comfortable than it is right now. HAR file import, and what we are working on right now to add to dynaTrace is improve benchmarking capabilities, because we've seen that those benchmarking results are somehow nice, but it really depends on what the page is doing. So you cannot compare the search site of Google to the CMS site of a major newspaper, and then said you can apply the same rules to both what is good, what is bad, regarding the number of images that are downloaded, the number of third-party domains, and the like. So what we're working on currently is providing you dynamic benchmarking, so you're able to select, okay, I want to get a benchmark for an e-commerce site. What we do, we take the Alexa 1000, split them up into smaller groups, and say, okay, compared to all other e-commerce sites, you're that good or that bad. So we're not taking it from the purely technical best practice perspective, but also give you some hints how you compare to others in the same domain that you're working in. So that you, if you're a CNN, you compare to CBS, and not necessarily against Google, where we'll have not a lot of chances to compare against. That's will be the major feature that we're going to implement for the upcoming 2.0 release that's coming out in November. Question always asked is Firefox support. When are you guys going to support Firefox? And I know we've been talking, okay, we're going to support Firefox for quite some time now. And I asked our CTO, so what should we say when supporting Firefox? And yeah, the point is that we're working on it. We can't give exact dates yet. What we simply can provide to people right now to just drop us an email as soon as the beta is available, that we put you into the beta program. We shifted Firefox support a bit back because we were working on a commercial version of Ajax edition. That's why it got shifted back a bit right now. It is on our agenda. It is one of the hot points that we will be working on soon after the 2.0 release. The feedback that we saw one from the community is, what do you mean by Firefox support? Tell us which versions of Firefox you want to have supported and which platforms you want to have supported. Because unlike other plugins, we need for our precise timings some native components, so we would need against which platforms we would have to compile. So for us, it is a difference to support Firefox on Windows than it is to support Firefox on Mac from an engineering perspective. So simply tell us what you want, and we will look into which platform to roll out first. Without saying anything, I think that the top platforms that we'll be looking at the beginning will definitely be Windows, because it matches then the whole IE stuff. And the next one definitely will be Mac, the latest release of macOS. Another great announcement to make is I exchanged just a couple of tweets and emails with Pat Meenam from Web Page Test and asked him, so what would you think about having dynaTrace results in Web Page Test? And he said, yeah, that's a good idea. I'll have a look into it. And I just touched base with him yesterday, and he said, yeah, I implemented a prototype of it. It's already now up and running, just having some minor issues, and we'll make it available. So first of all, thanks to Pat for really building this. And the plan here will be that when you run a test on web page test, you will then also be able to download the dynaTrace sessions right after you run the test. So the DTS file, the exported file, you can download it and then have a look at it locally, how your website behaved from a certain location. So that's one of the great news of upcoming integrations of dynaTrace. Another big topic for us is Internet Explorer 9. There were a couple of tweets that said, well, with Internet Explorer 9, nobody will be using dynaTrace Ajax edition anymore because it's that super fast and nobody needs JavaScript profiling anymore. You guys are out of business. Well, we see it a bit differently. Don't get me wrong, there have been major improvements in IE9, but what we've seen is people are building more and more heavy JavaScript applications, and profiling is helping them to improve their code, which might not run faster on IE, but still you need profiling capabilities. You need this kind of means to continuously track the performance. So this industry, or this whole area of performance optimization, is just growing. And I think that there will also be a space in the future for dynaTrace Ajax edition. When it comes to support for IE9, currently we know that we're not supporting it, which is basically because Microsoft changed all their interfaces that we used for getting all the metrics we're collecting right now. And we're currently on the way to research how we can get access to those interfaces, which, as a side note, would be nice if browser vendors would just have kind of at least somewhat standardized interfaces to get into the rendering engine, to get into the browser. It would just make our life for supporting multiple platforms much easier. But in most cases, those interfaces do not really exist. So coming to IE9, we don't have a fixed plan for supporting it, but it's definitely on our top priority list right now. So we'll look into it, and as soon as we have something, we'll keep you posted as well. Yeah?
So does IE9 look to you like a new platform?
Except the networking stuff, yes. Because it has all been re-implemented. And, just repeat the question for the people on the phone. The question was whether IE9 looks to us as a completely new platform. And from the diagnostics tool point of view, it is true, because the components are simply different. So how you get into those browsers today is you simply have to find your own hooks, how to hook into the rendering engine, how to hook into the JavaScript engine, in order to start working on building a performance management toolkit, which is quite true for every platform. But that's why IE9 for us is really a new platform. And that's where we hope in the future that browser vendors might open up those interfaces for performance tool vendors like us at some point, or have some kind of standardization that we could rely on. It would just make our life easier, and we could focus more on implementing the performance analysis stuff rather figuring out how we get the basic information out there, which we know is not that easy to achieve for those guys as well, because they have their technical restrictions as well. So now let's switch to the demo. Now let's see dynaTrace in action. So we have a couple of minutes left. Sorry for the guys on the phone, but I hope you get a chance later on seeing this on the video. So what I prepared here is a simple test case. I just show you the automation part and look at the rest later on. What this test case does is nothing really special. First of all, it writes out hello world. Then it uses simply WebDriver to go to the Yahoo website and type in dynaTrace as a search term and then submit this. This is a simple WebDriver test. Some might wonder, what is this code doing here, where you're loading a local URL and then you're waiting 300 milliseconds. That looks quite of a hack in there. The reason for this code is that when you start Internet Explorer the first time, and the first page that you're going to takes longer to load than all subsequent pages. It simply initializes the whole infrastructure in there. At least it was up to that to IE8, where we know it. So the recommendation is just load some page that you don't care about, wait some time until the whole system is initialized, and then start your actual test. And here the related build file for that. So the only thing that I had to change here were actually those two lines down here, where I simply added two new environment variables. So I didn't modify the test itself at all. I just added two environment variables, which just tell me activate the dynaTrace agent and the name of the session that will be stored later on, and which we will see in the dynaTrace client. And additionally to adding the environment variables to the Ajax edition, the only thing that I have to do right now is to run that test. So we see Internet Explorer starting, and that's it. So what we get here is, first of all, we have a new test run. Don't take the ranking seriously because I'm here on maybe a bit slow network. And here you exactly see that point that we have a first impression time for that first page of nearly 2 seconds. If I haven't put this into the test, you would have Yahoo having a first impression time of up to 3 seconds, which we all know is not true. So this is the interactive analysis part in here. Okay, Yahoo gets very good ranks on dynaTrace, so it's not that impressive. But what happened in the background as well is that we sent a beacon to an endpoint that contains all the test data. In this case, it was just the Yahoo URL. So what we see here is you get all the rank information. You would also see comments. So if we rank something lower, we provide you some initial comments why we ranked it lower, like 200 network requests, a lot of slow JavaScript handlers, CSS files that could be merged. So we write also a human readable comment in here. Okay, in this case, we want to redirect 3 dynamic server requests and 4 slow JavaScript handlers. So don't be worried about those 4 slow handlers. These are the script blocks that simply initialize the page. So it doesn't mean that everything that we rank as slow is actually slow. It just means that there is something that we saw. And on the lower part, you see here the first impression time, time to unload, fully loaded, the request numbers, XHR times, and all those metrics that we send right now. As you see, there are a couple of those still set to 0. That's not an error. That's just what we're working on currently in exporting. So that will be the metrics that you will get for automated tests. So we simply send this JSON beacon to any endpoint and can process it, and you can yourself think of what you're going to do with this data. Whether you're going to process it or put it into a repository, visualize it as charts, or do with it whatever you want to. And as you've seen, the only thing that you have to add to your current performance test is just configuring Ajax edition and adding 2 additional environment variables, and that's what you get for your test run, actually. So just to finish up here, I'd like to just show you one other example on how to use dynaTrace from an analysis perspective. So I built a really complex web application with 2 diffs in there, and I can increase that 1 diff. Okay, that's not the really interesting part of it. What, however, gets interesting is from a rendering perspective. I deliberately took this very simple sample here, like what I see here in the in this view. I see here exactly this button click. So I can also search in here. So I can just search for a certain button in here, and okay, expand the subtree. And as I told you before, I can immediately move down here, see my stack element with the major contributors, or search in here as well. Well, what I'm really interested in here is what forced a scheduling task to be scheduled. or what forced a scheduling, an actual rendering to be triggered. So I can find out why rendering was actually triggered, and I can then walk up all my way in the code why this is happening. So classical cases, what we see is people modifying CSS properties and then reading out some CSS properties that they force immediately recalculation of the layout, and doing this in loops, ideally. So that's just from a rendering perspective, just showing you the PurePass dashlet very shortly here, how you can use it. So you can really drill down into a JavaScript code and have a look at it. Alternatively, if you have a whole page and want to know, okay, what are the critical components, it's here looking at the rendering part and getting also immediate back traces, so who caused rendering in my application, who triggered rendering, who triggered the schedule, or which part of the code triggered the execution of scheduling, re-rendering in my application. And for sure, if I have found something, yeah, that was actually funny. I found that yesterday there was, when I served to Yahoo, that I get a couple of JavaScript errors. Sorry, guys. As I said, the alternative to analyzing JavaScript would be to go right to the JavaScript tab over here, where you guys are doing a really good job. There's not a lot to see. So all your JavaScript is fine for dynaTrace. Nothing is as slow that we really... Oops, that's the wrong session, sorry. That was just my really sophisticated web application. And taking this one here. So here what you see is the same. Here we take all the handlers that take over a certain amount of time. And you have the same analysis functionality like doing a forward trace. So what did this method call here? In this case, it was a set timeout call, as well as back traces, which are especially important if you have CSS selectors. So who actually executed the selector? Which button click was it? Which interaction was it? Or which JavaScript block was it? And at the same time, seeing on the lower pane the JavaScript code that is associated with it. So we actually found ourselves mostly working in this pane when we're doing an initial analysis of a page, because mostly those, here we see it, mostly those JavaScript handlers that we find in here help you identifying where the critical parts in your applications are. And it's especially useful for users that are not that familiar to JavaScript code and some get overwhelmed by seeing everything at once, especially for an application you haven't built yourself. It might be a good starting point to have a look at this right here. Yeah, and as mentioned before, there are all those added tabs like the server-side parts, showing you what we have seen from a server side. You guys are doing great here as well. Networking side, caching, and for sure the KPI parts that you could use. You guys are simply too good to really have any red numbers here, which might be more impressive then. So just to sum it up from an analysis perspective, you could really start here from the benchmarking perspective. You would just need this tab up here. Then you could really go down into where you could optimize, drill down into the specific areas of your application, or at the end really do the deep dive into the actual code execution, which specifically is what framework engineers and JavaScript engineers are interested in. So that's it. I think we're good in time.